I am currently the chairperson for public education and outreach for the Royal Astronomical Society of Canada, the Calgary Chapter. So that's kind of our Calgary club. And like I said, I'm going to go through the solar system, and you may learn a few things you weren't aware of. And if you have any questions, I'm going to stop probably around every maybe 10 slides and answer your questions. So here we go. And we're not, there we go. Okay, that's just, so first off, our solar system. To be honest, even with the James Webb telescope that we put out there on Christmas Day several years ago, we have never come across a solar system similar to ours. We have come across stars that have planets orbiting them called exoplanets, but really it's the equivalent of ours. But we've only ever found maybe one orbiting a star, never a group like ours, like with 8 of them revolving around it. That is unique so far. How did it form? Well, probably around 4.5 billion years ago. It was just a dense cloud of gas. And something caused it to start to rotate. Now, whether that was a star that had exploded somewhere off into the distance and then the shock wave just disrupted the gas and caused it to start to rotate. And as it rotates, you start getting that gas cloud to collapse down. And once that happens, you start to get a little bit of gravity happening there too. And so that is really how ours started. And to be honest, our solar system is still evolving. And we'll go over that as well. We are nothing in the solar or the universe for that matter is static. Everything is constantly moving and changing. So here's our solar system. Now, I'm sure you're all very familiar with the long play record album, the old LPs. Well, all the planets that orbit our sun are pretty much on the same level. So just like on a record LP, you can see all the individual songs. Well, this is like all the individual planets. We're all very level with each other. Now, there is one that doesn't play by the rules, and that's Pluto. We'll talk about Pluto later on, but that is called the ecliptic. And the sun, you'll always know where the ecliptic is because it's wherever the sun is. So you'll notice in the summertime, the sun is very, very high in the sky. All right, and that's because we're tilted toward the sun, at least the northern hemisphere is. Whereas in the wintertime, the sun is quite a bit lower in the sky, and that is because we're pointed away from the sun. But all the other planets as well, they all tend to rotate counterclockwise. And there's a few that don't follow those rules either. So here's a good example of what's happening out there. So of course you can see Pluto's orbit, which is like way out there, whereas the other ones all follow pretty much the same little pattern. Of course, the planets that are further out take longer to go around the sun for obvious reasons. So the sun. Now, the sun has been kind of, although we have been mentioning the aurora has been making the news, it's more the sun is causing all of that. And I know we talk about climate change as well, but we also don't talk much about the sun, which is a huge part of that climate change. It's essentially just a middle-aged yellow dwarf star. It's not huge, it's not tiny, but it's a gigantic thermonuclear reactor. It is. It is. And I am very glad that we are not too close and not too far away. Light traveling at 300,000 kilometers an hour, it takes about 8 minutes and 20 seconds to reach Earth. So everything, when you look into the night sky or even the day sky, you are looking at what it used to look like. So if something happened to our sun and it just suddenly winked out, we would still get light for another 8.5 minutes before we knew anything had happened. Some of the stars that we look at in the sky, in the night sky, they don't even exist anymore. The light is still traveling toward us because they're so far away, but in essence, they've either exploded or shrank down into a black hole. But so it's like a time machine when you're looking up into space. Now, getting back to the sun, we are reaching, it's got a like a rotation that goes through it. So, and it usually happens around, it peaks at around 11 to 12 years. And we are right in that 11 to 12 years right now. Now, as we go through that cycle, the sunspots become more and more visible on the surface of the sun. And it is from these sunspots that we get the ejections of electromagnetic energy. Now these black hole or these sunspots, they look black when you look on the surface of the sun, but if they were by themselves, they would be very bright. You wouldn't be able to look at them. They're only dark because they're not as hot as the rest of the sun. But what they are is, you have to remember the sun and the earth and the planets, we're essentially gigantic bar magnets. We have a north pole and a south pole, and we have electrical energy going from one to the other. So when the solar wind hits Earth, it's coming from these sunspots, and those are actually just kind of where the electrical magnetic energy on the sun just got so twisted. It all of a sudden it's almost like a static charge coming out of these spots. And if that energy is directed straight at Earth, that's when we get these tremendous displays of aurora. Now, there is a dark side to the energy coming off the sun. Again, you have to remember, this is electromagnetic energy, which is, we live on a planet that is run by electricity. So if we had a tremendous outpouring from the sun from one of these sunspots and it hit Earth directly, walking around, you wouldn't notice anything, but it would disrupt all your cell phone coverage, your electric vehicles, the satellites orbiting in space. It could generally take down our electrical grid, which would be not a good thing. So anyway, the sun is our friend, but we also need to respect it very much. Now here's a good example. I don't know if you can see my mouse, but here you can see the solar wind coming off the sun. And this happens all the time, but you also get these bursts of energy coming out of those sunspots. Here we've got the Earth, and again, we are a bar magnet, so of course we've got this incredible force field around us, and thank God we do. When that solar energy does hit our force field, like a bar magnet, it always will direct the energy to either the North or the South Pole, and that's where we end up with the aurora. And we've had some tremendous displays this year, and I think that we'll probably only get more of those as this next year goes on. But you have to remember that energy coming from the sun it's deadly. Let's just call it what it is. It's gamma rays, X-rays, radio waves, every type of energy that could be coming, and it is our force field around our planet that keeps us safe. And without that, we would not exist. So a lot of things have come into play to keep us nice and safe. So we're going to talk a little bit about Mercury. So Mercury, of course, closest to the sun. The only time you'll ever see Mercury and Venus, for that matter, is after sunset or just before dawn. And that is because they lie between Earth and the sun. And they're very close to the sun, so that's why they follow it at dawn and dusk. Now, I always say, if our solar system was a football field, the sun would be at the goalpost, and Mercury would be not even on the 1 yard line. That's how close it would be to the sun, whereas Earth would be on the 2 yard line. Only takes about 59 days to orbit to orbit on its axis, and then its day. It takes only 88 days to orbit the sun, so that's its year. It still takes sunlight 3 minutes to get there, even at the speed of light. Let's just call it what it is. It's very heavily cratered. It doesn't have an atmosphere. If it did have one, it has long since been boiled away. The average temperature there is 430 degrees during the day, and if you cross over into the shade, it's minus 170. So things are not too livable there. Yeah, if it did have water or anything, it has long since vanished. There's a good idea of how the size of Mercury compares to our moon. It's a little bit bigger than our moon, but not too much. In interesting thing about Mercury is it actually has a tail that you can see under certain circumstances. Now, you have to remember, getting back to the sun, we have this solar wind coming off the sun, and that's literally all its energy coming off, whether it's in the form of gamma rays, visible light, X-rays, things like that. But what it does is it actually acts like a wind, and it pushes stuff away. So any of the sodium that the atoms of sodium that are on Mercury, when you're up against the solar wind, the light from the sun will push the sodium away. So again, the same with a comet. Here we got the tail. The tail will always face away from the sun, never faces towards it. So it's pushing that solar the sodium away from the planet Mercury. So the sun would be over here, going in that direction. So I've never seen the tail itself, but it is quite remarkable to see it. Venus. Oh my goodness. What can we say about Venus? All I know is we will not be going to Venus anytime soon. Again, if we're on the 2-yard line, Earth, Venus is a little bit closer in the 1.5-yard line. It has got many strange things going on. Its year is actually shorter than its day. That's how slow it rotates. It also rotates backwards. The rest of the planets rotate in a counterclockwise direction. So the sun comes up in the east, goes down in the west. Not Venus. Venus does it the other way. Now there has been, and it spins backwards, so anyway, there has been some talk that they actually believe Venus is upside down, which could explain a lot. Now what happened to it? You have to remember that when the solar system was forming, there was a little bit of celestial bumper cars going out there, and quite a few of the planets took hits from other objects. So the theory right now is Venus is upside down, which explains why it's rotating backwards. Now, it could also explain why it's barely rotating. It takes 1 day on Venus is 243 days. I mean, that's a long time. Now, it has an atmosphere too. In fact, it has way too much atmosphere. So when we talk about an atmosphere, like say on Earth, we've got nitrogen, we've got some oxygen, we've got a few other elements, but that is really the gaseous kind of envelope that is around Earth. Well, Venus takes that to a whole different level. It's acting almost like a blanket. So any of the heat it's receiving from the sun never can escape. And it's also, let's face it, it's mostly carbon dioxide and sulfuric acid, so things are not good there either. Now, considering Venus is not the closest planet to the sun, it is the hottest planet in our solar system at about 460 degrees Celsius. Now, that's bad in itself. Now, Mercury, nobody has landed a probe on Mercury. None of our countries have. So the only images we have of Mercury have been by kind of flybys. Now, Venus, on the other hand, Russia stepped forward and they've landed several probes on Venus, but none of them lasted more than 2 hours. And that's because they were crushed flat by this atmospheric pressure of, well, right there, 1,300 pounds per square inch. Now, on Earth, we have an atmospheric pressure of about 14 pounds per square inch, and yet we don't even notice it. That is pressing down. That's all the gas that's directly over your head, and we don't even notice it because our life forms have evolved with that type of pressure pushing down on us. Now, if we went into space and took off our flight suit or our space suit and was exposed to the emptiness of space, things would not look too pretty because our body would be pushing out at that 14 pounds per square inch, and I'll just leave that visual to you. But if we went to Venus with a pressure of almost, well, 90 times our atmospheric pressure, the poor little probes that they have managed to land on Venus, they get squashed flat and then they melt. Now, we do have, okay, I'm just actually going to go here first. These are really the only images we have of the surface of Venus. And they were taken just before the spaceship was crushed flat and melted. And you can see it is a pretty barren landscape out there. They are thinking of having some other probes go there. But yes, it's a very hostile planet. Now, an interesting thing about Venus, you'll see Venus, like I said, in the evening sky or in the morning just before dawn. But it will always look brightest when it's a crescent. So it has all the same phases of the moon as well as our moon does. It has crescent, it's full moon, it's a gibbous, or it's waning, or it's half. But I asked this to one of our astronomers. I said, when I look at Venus in the night sky, and it is so bright, and then other times not as bright, and I'll look at it through my telescope, and it's actually a crescent, it's not a full moon. And it has to do with where it is. So when it's in the crescent shape, that means it's closest to Earth, which makes perfect sense. And then when it's on the other side of the sun, when it's a full moon, then you'll notice that it's not very bright at all. So that's an interesting thing about Venus, is it does have the phases similar to our moon. It's pretty much same size as our Earth. There you can see compared to the moon. But as you see, our beautiful Earth here is just this beautiful blue orb. Venus is just a nightmare of heat and pressure. Those again, the images. So this whole greenhouse effect, there has been lots of theories that Venus was very much like Earth earlier on in its development, that it had lots and lots of water, had an atmosphere. And for whatever reason, it could have been because it collided with something which knocked it completely off its axis, has it rotating backwards, slowed its rotational spin down to practically nothing. We're not sure. We're not sure, but it's just not a livable planet for us, for sure. Earth. This should be an easy one. This was taken by Bill Anders. He just recently passed away. He was one of the astronauts on Apollo 8. That was the first time we'd ever actually had one of our capsules orbit the backside of the moon. It was the first time we ever saw the other side of the moon. It was quite an achievement. And they just happened to see, instead of the moon coming up, it was the Earth. And it was just such an incredible photograph. And I have had the great fortune to have met Charles Duke, who was an astronaut with Apollo 16, walked on the moon. And he said, it's absolutely like that. You don't see any stars when you're walking around on the moon. The moon is, or the sky is absolutely black. And then you've got this beautiful marble, blue marble, just hanging out there. So yeah, I just love that shot. So the thing that makes life livable on our planet is the simple fact that we have liquid water. Water can be in a liquid state on our planet, which means we're close enough to the sun that ice melts, but we're not too far away where the water would remain in a frozen state. Now, how that works is when you have liquid water, it leaks down into our crust. So the crust is the hard part surrounding our planet. And like water is known to do, starts forming little cracks and percolates down there. And so it cracked that giant crust into movable plates, which have turned into our continents. And they're floating around there. The inside of our Earth is a live, living planet. We have a hot central core, and from there heat radiates up in the form of convection currents. And anytime you have currents going, you're going to have electricity forming. And that is what has created our magnetic field, which protects us from harmful solar radiation. So without that liquid water, we would not have that magnetic field. So that is the key for our life form anyway, that you have to have liquid water for us to exist. They call it the Goldilocks zone. Earth is just in the right spot at the right time. And we've had life evolved here in many, many, many different forms. We've also gone through at least 4 or 5 mass extinctions where almost all life on Earth was eradicated, either due to meteor striking the Earth or possibly a star going supernova next to us. So we're just in the perfect spot on such a beautiful planet. How did How did our moon form? Well, again, we talked about celestial bumper cars. Well, something collided with Earth a long time ago when we were forming. And they think it was maybe the same size as Mars. But I mean, you have to remember this is a theory. Um, it was a good thing something did collide with us. Of course, it blew apart both of the objects. They both consolidated down, one to the moon, one to our planet. But it knocked us over at about 23.5 degrees, which does change over the millennium. But right now, that's how far we're tilted, which is a good thing for us because it gives us seasons. We'll have spring, summer, fall, and winter. Now, without that tilt, the poles would be forever pretty much in twilight, and the equator would be just cooking hot. So, in a way, it was a good thing that something collided with us. Some facts about our moon. It doesn't exactly follow the rules. It's in an oval shaped um, orbit around Earth. Sometimes it's closer to us and sometimes it's further away. When the dinosaurs were walking around Earth, it was 1,000 miles closer to Earth than it is now. It is very, very slowly moving away from us. It doesn't have a dark side. It just is what we would call being tidally locked. So it means the one side of the moon generally always will face Earth. You can see probably about 59% of the moon because there's a little bit of a wobble and a nod when it's going around. Now for astronomers or anybody just interested in looking at the moon, you never want to look at the moon during a full moon because you won't see anything. It's just all washed out. The best time is what we call the first and the last quarters, which is where from Earth you're looking at half of the moon, and that makes all the mountains and craters show up much better in binoculars or a telescope because it allows for the shadowing to pass around the side. So we just had a solar eclipse here in April, and why don't we get one of those like every month, right? Should work that way. Well, a solar eclipse, we get one of those about every year and a half. But the thing is, sometimes that solar eclipse will pass over the Pacific Ocean or Antarctica or some area of the Earth that is not largely populated. The reason the one in April made world news everywhere is because it passed over the continental United States up into Canada. So it was literally millions and millions of people that could witness it. There is on my little diagram there, you can see that the moon passes between the sun and the earth. Well, the moon isn't very big, so of course it doesn't have a very big shadow. Okay, and then that little shadow moves across the planet. Now, a lunar eclipse, on the other hand, is the opposite. It's where the big fat moon is between the sun, or the big fat Earth is between the sun and the moon. Now, because we are so much bigger, the Earth causes a huge shadow to extend out into space. So we get lunar eclipses, which is when the moon passes into the Earth shadow, as opposed to the Earth passing into the moon shadow. They occur quite frequently, like 3 to 5 times a year. And it's really quite interesting to watch those. Very safe. You don't require any special glasses or anything. And the moon becomes quite red. So it's very interesting. So we generally have lots of lunar eclipses. Now, one more thing about the moon. I'm sure you've probably noticed this and just never really thought about it. Sometimes the moon is very, very high in the sky, and sometimes it's very low in the sky. And that's because, again, it doesn't follow any of the rules. So this is that ecliptic plane, and it's called the ecliptic. It's because that's where the eclipses occur. But you can see that the moon's orbit is 5 degrees either above it or 5 degrees below it. So in order to have a total eclipse of the sun, you've got to have this thing when its orbit is back down on the elliptical plane. But that's fine. Sometimes you'll see the moon up high, sometimes you see it down below. And there you can see its orbit. This really has to do with supermoons, so you can see when it's in apogee, it's furthest away from Earth. This is not to scale, but in perigee is when it's closer. So this is when you would get that supermoon. Now, this is in perigee, so this is closest to Earth. And this is an apogee when the moon is further away. So you can see that when you do have a full moon during that period, that the moon will appear a little bit bigger. All right, any questions at all regarding the sun and our first 2 planets?
We do have a couple of questions.
Okay.
Do we know why Pluto's on a different rotation than The rest?
Well, we're going to talk about Pluto. We will. Again, it is what we consider really a large asteroid. We've actually found four other objects of that size in the Kuiper Belt, and as they are rotating around the sun. They definitely are doing that, but I would suspect it's most likely because it collided with something. I mean, we sit on Earth here and we think we're so safe and happy. And we have to remember we are on a planet spinning through space, and things do collide with us. And I think that's probably what happened with Pluto. It just ended up, it's very close to Neptune, and sometimes the gravitational forces of Neptune will pull on it. And that's how you end up with comets coming from that Kuiper belt, well, we'll talk about Jupiter too and what happened to a comet that got too close to Jupiter. So I hope that
Okay.
answers your questions.
Yeah. Um, is there climate change on other planets?
Yes, there is. And
Ooh,
Mars is a perfect example of that.
all right. Well,
Mars,
we'll answer that one later.
yeah, Mars is coming up here, but climate change has existed since the Big Bang. Nothing stays the same. Um, I mean, we used to be under a mile of ice here in Calgary when we were having ice ages, and those ice ages will return in the future. It has to do with the orbit of the Earth around the sun and how we're tilted and things like that. Like when you talk about orbits around the sun, our orbit is not perfectly circular. It's more what we call elliptical. So it's a little bit oblong. And depending on when all those things line up, we go into a cooling phase where we get the ice ages. And we're also into a phase right now where those glaciers are melting because we're moving into a warmer phase. But you have to remember that this is Mother Earth doing this. I mean, mankind certainly has an impact on it, but to be honest, nothing nothing disrupts Mother Earth. But yeah, climate change is on every planet, every star, everywhere.
Okay. And do we know how they found out the temperatures of Mercury?
Oh, well, we haven't sent a probe there because again, it would melt pretty much in a half an hour, but they're able to, they were not so much orbited it, but they did a flyby and then they're able to direct images and stuff or how you would put it. But anyway, they're able to detect the temperature of that. And
Okay.
then as they're going past onto the dark side, they can also see, because there's no atmosphere, any heat that hits Mercury just goes right back into the atmosphere. And you're either frozen or fried.
Okay.
We're not
We
going to
have
Mercury
one
either.
about Venus. Uh, why do they consider it upside down? What are the key indicators that it's upside down?
Because it doesn't orbit counterclockwise. Every
Okay.
other planet in the solar system goes counterclockwise. So the sun
Okay.
comes up in the east, sets in the west. Venus is backwards. The sun comes up in the west, sets in the east. It also has almost hardly, I mean, its year is the equivalent of its day. I mean, it
Yeah.
rotates so slowly. Something has disrupted that planet to a huge degree. Whereas it takes, I mean, its year is actually shorter than its day. But that's why they are questioning that, or I mean, right now, you have to remember the TV show is called The Big Bang Theory, and a lot of what we think about our neighboring planets is a theory. So that's currently the one we're looking at right now is something
Okay.
struck Venus and it's upside down.
Okay. Last one. Uh, do we know if the Earth ever had a concentrated atmosphere of CO2 and H2S?
Possibly. I mean, you have to remember when we were forming, we were not a nice place to be. I mean, we were basically a collection of gas. It was condensing down into the rock and stuff like that. And then we were a very, very hot planet. We had so much heat coming off. So there was volcanic eruptions that went on for probably a billion years. Well, we know what kind of gases come out of volcanic eruptions. So the atmosphere would not have been breathable. There would have been no oxygen. It would have been nitrogen, sulfuric acid. I mean, it would have been just absolute nightmare place. It was only after the Earth started to cool down a bit, and by some miracle, we ended up with life coming to our planet, and it was the trees, it was plants, and that put that oxygen into the air with their photosynthesis. And they think the water ended up on Earth just from a millennia of probably comets striking the Earth. And comets are literally dirty snowballs. They're just really frozen water, a little bit of dust, and a little bit of other goodies. But I mean, just think about how many of those dirty snowballs would have had to hit Earth to give us our water. So, I mean, there's just so many things that happened on Earth that the odds of happening are just we're here by a miracle. We truly are. We're in the right space, right time. And yes, there were times in our distant past where our atmosphere was lethal to any living thing. So especially caused by the volcanic eruptions.
All right, speaking of lethal atmospheres, let's go to Mars.
All right, so Mars. I'm sure a lot of your viewers have probably seen the movie The Martian with Matt Damon. And I must admit, they actually did a very good job with that. It's based on a book. And the only thing they kind of went off on a bit there, probably not as realistic, was the wind. Mars doesn't have a tremendous amount of wind that would actually blow over your spaceship there. But everything else, I think they did quite a good job. So, fourth planet from the sun. So if we're on the 2-yard line, I can't remember exactly where Mars is. I think it's on about the 4-yard line, so a little further out. It's red, and if you've seen it when it's in what we call opposition, which means it's closest to the Earth at that point, it definitely has a red color, and that's because all its rocks are rusting. That's what's happening there. It has a really weird orbit too, and it's mostly because Jupiter is pulling on it. Jupiter is this massive planet. It's got a huge gravitational field, and poor little Mars is getting tugged on by Jupiter there. It's got a tilt similar to ours, about 25 degrees. So it does have the 4 distinct seasons, but they're twice as long as on Earth. The average temperature, the mean temperature, is minus 65 degrees Celsius. Now you have to remember when they do a mean temperature like that, that's from the dark side and to the sunny side. So it's got 2 moons. I would hardly call these things a moon, Phobos and Deimos. Like Phobos is only 22 kilometers in diameter, and Deimos it's only 13 kilometers in diameter, and they're shaped like potatoes. Um, really, from what most astronomers think, they're probably captured asteroids. An asteroid just got too close to Mars, and it kind of got captured by its gravitational field, and so you got 2 little mini asteroids orbiting the planet. But I mean, my goodness, they're not even circular. Um, it does have an atmosphere, but again, it's not breathable for humans. It's 95% carbon dioxide. Now, what poor old Mars just didn't have the size, and we'll show you how it compares to the size of Earth. But again, compared to Earth, we are a living, breathing planet. We have a hot core, and that core is still giving off heat, which generates the currents, which generates our magnetic field, which protects us from the sun. So Mars wasn't that big, and so it cooled off. And I believe that Mars, I mean, this is probably a known fact now, that it used to be very similar to Earth. It had oceans of water. It was actually quite nice. It was doing quite well, and that's because it had a hot core back then. And but it just couldn't retain that heat. So when we talk about plate tectonics, that's where the liquid water leaks down into the crust around the Earth and breaks it into chunks, and that's plate tectonics, where those continents are moving around. It didn't have enough heat for that to happen, and when we didn't have the continents moving around, and the core cooling off, we lost that protective magnetic field. It did have one at one time. It still has one a little bit, but to be honest, what atmosphere it has is gradually being stripped away by the sun's solar wind. And when I mean stripped away, it's literally just being blown away. So eventually Mars won't have any kind of atmosphere. It used to have, like I said, an abundant water. And you can see that on the surface of Mars. You can see where the water has formed canyons and things like that. There is still some frozen in the polar ice caps. You can, on a clear night, you can actually see the white polar cap on the north end. And it's also it's locked into minerals in the planet's crust, but the rest of its water just escaped into space. So for all intents and purposes, Mars is a dead planet. Its core is cooling off. It's losing its atmosphere. You talk about, oh yeah, we're going to go live on Mars and stuff. Well, once the atmosphere is gone, we're going to have to live underground because there would be nothing to protect us from the solar radiation. Um, yeah, just just too small. Now there's its orbit. You can see that you got Earth's orbit, and which is kind of a little oblong, but Mars is way, way out there, and it's just because it's so close to Jupiter. Now we've got lots of photos of Mars. We've landed multiple satellites or probes there. Uh, you can see that it's bigger than our moon, but not by much. And you'll see that the Martian moons don't even show up. They're so tiny. Um, but it does have two amazing claims to fame. It has the largest volcano in the solar system. And it's Olympus Mons, and it's 3 times the height of Mount Everest. Now, last time I checked, Everest was, I think it was 29,000 feet, so it'd be about almost 90,000 feet. And the reason that volcano got to be so big has to go back to that fact that Mars lost its ability to have plate tectonics. So if its continents just all kind of stuck together and never moved, then that hot spot coming up from the core never moved. And so that volcano stayed in place and just got bigger and bigger and bigger over time. There's a great picture again of Olympus. It's just a massive. Now it hasn't erupted in millions of years, and as Mars is cooling off, it probably won't erupt again. Now, the other thing is Mars has got this massive crack, the Marianas crack, I believe it's called. I mean, it takes up, I don't know, it's like a quarter of the surface. And I mean, you can see how it compares to the Grand Canyon. The way people kind of think about this is, why did that happen? And again, Mars lost its water and it's essentially drying up. I mean, and think about a grape that is starting to dry up and it starts to shrink and it starts to crack. And that's exactly what happened here. Is we think that it's just a matter of it's just slowly drying up. It's very sad, but it is a massive, massive crack. Then we have, between Mars and Jupiter, the asteroid belt. Now, a lot of people used to think that it was asteroid belt. That's was a planet and it broke apart and it's just pieces of stuff orbiting the sun there. And to be honest, it's just kind of leftover material from when the solar system formed. It seems like there's a lot there, but really it's one little chunk of rock, and then you won't find another chunk of rock for like 100,000 miles. So it's not like it's just everywhere. It's pretty much spread out, but it's just kind of leftover building blocks. Yeah, this is pretty much just what I've said. This is going back to our football field. This is between the 4 and 8 yard lines. So it's between Mars and Jupiter. There's thousands of objects there, but most of them are just like specks of dust. There is a few bigger ones. There's one called Cirrus, which is as wide as Alberta, which would make it a fairly large object. But to be honest, if you were driving your car through the asteroid belt, you'd probably say there's nothing here. So those objects are pretty far apart. Now I'm getting to the granddaddy here, Jupiter. Jupiter and Saturn, I think we just have to call them what they are. They are failed stars. If they had been a lot bigger, they would have had a tremendous amount of pressure on their core, to the point whenever you have something that's being squeezed, it heats up. and it would have been enough to ignite a thermonuclear reaction in the core. So I don't think I'd be here giving you a talk if we were in a solar system that had 3 suns running around in it. I think that would have pretty much eradicated all life. So thank God Jupiter and Saturn didn't get too much bigger. But they have no hard surface. They're just really a ball of hydrogen and helium gas, which are the building blocks for all stars. Um, if Earth is on the 2-yard line, Jupiter is way out there on the 10.5-yard line. So they're 5 times as far away from the sun as we are. Massive, 1,300 Earths could fit in size. Brightest planet. Uh, rotates very quickly. When we have public viewing nights and we have telescopes on Jupiter, you can see the 4 biggest moons with a pair of binoculars. They're big. And they will move over the course of, say, 2 hours. You're looking at Jupiter. Those moons are moving. And we often say, okay, you better hurry up and come over here because one of the moons, Ganymede, whatever, is about to go behind Jupiter and we're going to lose sight of it. So it's amazing how fast things move. Now, again, like I was saying at the beginning, how looking up into space is like looking into a time machine. When you look at Jupiter, that light from Jupiter, it's not so much the light from it. We only see planets because the sun is shining on them. Like they don't generate their own light. But you're looking at what Jupiter looked like 43 minutes ago, not like what it looks like now. Has a ton of moons, 95 of them. Ganymede is the biggest one. It's actually bigger than Mercury. It also has a few rings. They're not very bright, but very, very stormy. Winds are 500 kilometers an hour there. Now, interesting thing is it has a tremendous gravitational force because it's so big. And Shoemaker-Levy 9 was a comet that was coming probably from the Kuiper belt, which is just past Neptune. And it got too close to Jupiter, and Jupiter captured it. And so now poor Shoemaker-Levy 9, instead of going down to orbit the sun and coming back, it's now orbiting Jupiter. And its orbit was very, very unstable. Sometimes it was very, very close to the surface. And eventually Jupiter's gravitational field just tore it into pieces. And this is really an image of Jupiter showing those impact sites on Jupiter. Some of those impact sites are probably 10 times the size of Earth. So if one of these fragments of Shoemaker-Levy 9 had struck Earth, it would have been the end of us. So thank God they hit Jupiter. And that's why we've kind of called Jupiter, it's kind of like a cosmic vacuum cleaner. It does that. It just sucks in all those little specks that are running around there like mosquitoes, and it brings them in and they crash into Jupiter. So it's a good thing. They said that we've been very fortunate with Jupiter doing this because some of those objects very well would have struck Earth. So good on them. There's Jupiter compared to Earth. The big red spot. The big red spot has fascinated us for eons now, and we're really not sure what it is. They think it could be some kind of ultraviolet interaction with the chemicals in the atmosphere. You have to remember there's no hard surface. It's just hydrogen and helium. And you see these bands on Jupiter, and often those bands are going in opposite directions. So a tremendous amount of wind. But yeah, nice place to look at, but definitely not going there anytime soon. Any questions on Jupiter and Mars?
We do have a couple. So how does the 95% carbon dioxide of Mars compare to Earth?
Oh gosh. Okay. I think our atmosphere is like we're 21% oxygen. So that would mean we have what 78% probably nitrogen, and then we've got the rest of that fragment is of other things, so carbon dioxide. But to be honest, it's very, very small, a very minute amount. Our atmosphere is generally nitrogen and oxygen. So
All
yeah,
right. Okay. Are telescopes to observe planets available to the general public? If so, where?
Okay, so in Calgary here, we have a program called Telescopes for Members. So if you join our club, then if you don't have a telescope, we have multiple types. There's generally the four different variations of it, but you can come on out, and we have a couple astronomers that will kind of show you which one would be a good starter one, and you can rent it. You can rent it for a month, and they'll give you instruction on how to operate it. And so it's kind of like try before you buy. Like I said, there's different types. My type is a reflector because it uses, or actually it's a refractor. I'm not sure. It uses lenses and mirrors, so it's a reflector. But there's also the Dobsonian, there's the Neutronian, there's right now I have another telescope called the Sea Star, which is an incredible little device that one is. Um, I think it will just completely surpass all the other types of telescopes combined. If any of your viewers out there, just Google Sea Star, and you'll be amazed at what it's capable of. But
Okay.
yes, so if you try one telescope and you're not quite sure that's the one for you, you can always go back, rent one for another month, and then you'll be able to get a really good idea of which type of telescope would be good for you. But again, you can see a lot just with a pair of binoculars. So we also try to do baby steps. Start with those, find out if
Ba-
you really enjoy it, and then move on up.
Baby steps are good. Okay, we've got a couple more here. Are objects in the asteroid belt still coalescing?
They're so far apart. It's oh my goodness. I'm sure some of them are. I mean, again, they're always colliding with each other when they do meet up. So if you have two that collide, I would think more than sticking together, they probably would just fragment into smaller pieces. Um, I mean, to be honest, we have that problem orbiting Earth right now. We have put so much space rocket debris that is still orbiting up there. It is causing quite a threat to us. And whenever two of those objects collide, they never stick together. They always break into smaller pieces. And we've had several times where they had to, with the International Space Station, they had to get the asteroids, astronauts into the escape capsule and try to boost the orbit so it wouldn't be struck by this orbiting space debris that mankind has put up there ourselves. So generally, when two things collide, they tend to break apart and then they'll come back, which is what we think happened to Earth when something struck us. But yeah, I mean, there's always that possibility.
Okay.
I'm sure it
Last,
happens.
yeah, last question. And I'm going to let you answer this one and then we'll get back to business. This is going to go over an hour. So anybody who is not able to continue watching, this is being recorded and we will put it up on YouTube. So not to worry. Last question is with the gaseous planets, are their moons still mostly rock?
Yes. So Saturn, we're just talking about Saturn here. It has the most moons of any planet. It's got 146 and counting. And Titan again is bigger than Mercury. And they got a little bit of rock, but um, well, actually, the moons have a lot of rock. The rings are made mostly of what we call ice water. So when I say ice water, I mean like ice out of your refrigerator, that kind of water, as opposed to frozen methane or frozen nitrogen or things like that. So yeah, those the and right now, if you're looking at Saturn, we were out looking the other night. The tilt has made it so that the rings appear almost like a straight line going across. So not the best time to look at Saturn, but it does look kind of cool with this bar as opposed to being tilted so you can see the rings more often or better. Also rotates extremely fast. Takes sunlight hour and a half just to get here. Like, I mean, you're looking at something that's twice as far away as Jupiter. So Jupiter and Saturn race across our fall skies every fall. Saturn always comes first, and then Jupiter follows her across the sky. But without a doubt, Jupiter is much brighter than Saturn is. But oh my goodness, very, very windy. 1,800 kilometers an hour on Jupiter. And you
Whew.
can see compared to our little planet there. There you've got the rings. mostly made of ice, like I said, a little bit of rock. And they think what caused some of the rings was maybe a moon that just got too close and got fragmented up.
All right.
Ur-
Onwards.
Uranus. Okay, this poor baby really got the short end of the stick too. It's way out there. It's on the 38-yard line. So, oh my God, if Saturn's on the 20, this is almost twice as far as Saturn. Rotates extremely fast. Takes sunlight just 2.5 hours to even get here. Now, Uranus and Neptune are what we call ice giants. And they also don't have a hard surface. They're like a giant slushy, nothing that you could land on or walk around on. And they're mostly made up of ammonia and methane and those kinds of things. They're just so far away from the sun, they've just become like a slush ball. But the interesting thing about poor Uranus is you think Venus got the short end of the stick and got knocked upside down. Uranus is laying on its side, so it has been knocked 90 degrees. Um, so let's put it this way. It does have seasons because it's got a tilt, but summer on Uranus would be 21 years of constant sunshine, and winter would be 21 years of pitch blackness. It's got some moons, it's got some rings, but something collided with Uranus a long time ago, and it is just like that, laying on its side. Very strange. Yeah, so methane, ammonia, and water is pretty much, but again, we're not going to land there at all. And you can see it's very beautiful through a telescope. It's blue, very pretty. Neptune. Neptune is the furthest official planet out there. Uh, oh my goodness. Takes 4 hours for light to get to us. It's also got some moons, got some rings. Um, it is the stormiest of all the planets at 2,000 kilometers an hour. But the cool part around about Neptune is if you actually got down into the bottom of that slush cup, the pressure is so great that the carbon is squeezed under this incredible. You would end up with a rain, but it would be of diamonds, not water. So that's really the cool thing about that and that's really what a diamond is. It's carbon that's been squeezed under a long period of time. So Neptune is also a very pretty planet to look at. It's also blue. So I'm going to talk about Pluto here. Poor Pluto. Pluto in the 1930s, that was our ninth planet, but right from the get-go, the astronomers are going, well, it's smaller than Mercury, has a bizarre orbit that overlaps with Neptune's, and to be a planet, you have to meet three criteria, and the first two are pretty easy. One, you have to orbit the sun, okay. Two, you have to be circular in shape. So going back to those uh, so-called moons of Mars that are shaped like potatoes. Okay, so they definitely aren't a planet, those ones. You have to be circular in shape. And the third one is you have to be big enough and have a gravitational force to clear your orbit of other objects. So other pieces of rock and gas and stuff like that, which is what Jupiter is busy doing, acting like a vacuum cleaner out there. Pluto never could do that. It's got asteroids and other debris, and so that's why it failed to meet that criteria. And there was quite an uproar when it got demoted to a dwarf planet. And but anyway, we've found several other objects in that Kuiper belt that are about the Pluto is the biggest one, but there's other objects in that Kuiper belt almost as big. Now, when we talk about the Kuiper Belt, it is an area that lies just beyond Neptune. And here's a good example of Pluto's orbit. Totally does not follow that elliptical plane like the other planets do. And for about 200 and some years, it actually passes inside the orbit of Neptune. So little interesting things. It's not named after the Disney dog. It's named after the god of the underworld. And it also has undergone many collisions. It's laying almost on its side, and it also rotates backwards. So a little bit of Venus and a little bit of Uranus going on there. So something obviously had collided with it. Extremely cold temperatures, egg-shaped orbit. I mean, I can't see it with my telescope, and I think I've probably got a pretty big one. Doesn't have any rings, but it does have 5 moons. Interesting, we have got some images of what its surface does look like, and it's got glaciers, mountains, valleys, quite amazing. This is just a little thing that's showing how the various planets and their tilt. You can see Mercury is really no tilt at all. Then you've got Venus, which is upside down, Uranus, which is on its side, and Pluto is also going the wrong way. So there we can see the Kuiper Belt, which is right here. Similar to the asteroid belt, it's got a lot of fragments of ice and rock coming through here. And then beyond the Kuiper Belt, we got something called the Oort cloud. And that's kind of, we don't know a lot of what's happening out there. For our Calgary viewers, if the sun was on the north goalpost of McMahon Stadium, the Oort cloud would extend all the way to Fort Macleod, which is hundreds of miles away. So, I mean, our little solar system is massive, and yet it's microscopic on the whole scheme of things. So that's where the Kuiper Belt would be, right here. There's Pluto. Now this is also where Halley's Comet comes from. Halley's Comet comes from the Kuiper Belt, goes down to around the sun. All right. The comets that are in that Kuiper Belt are called short period comets because they'll go down, wrap around the sun, and come back, and they'll do it in less than 200 years. All right. So Halley's Comet's the most famous one of that. It should be back in the year 2061. Now, it has been doing that for millions of years. Now, every time a comet makes a pass around the sun, it gets a little smaller, just so you know. The Oort cloud, oh, got a frog here. If you remember back, hang on a sec. If you remember back in 1997, we had a comet called Hale-Bopp, and it was probably one of the most incredible objects I've ever seen. It was visible in the sky for like 18 months. It was 4 times bigger and 1,000 times brighter than Halley's Comet. Unfortunately, it comes from the Oort cloud, and so it won't be back for 2,400 years. Again, at the beginning of my talk, I said nothing lasts forever, and neither do comets. And so every time they do a flyby of the sun, they vaporize some of the ice and the gases that make them up. And eventually, all that ice and the volatile gases have been boiled away by the solar wind, and all you end up with is with a rock, just a small rock going down around the sun, coming back, but you won't be able to see it. So it's Halley's Comet, and Hale-Bopp. And here's Halley's orbit. Okay, so it's coming from past Neptune, goes down, and you think it looks pretty simple, all right? But you have to remember we have all these things running around in there. And like I said, Shoemaker Levy 9, as it was making its little trip to the sun, got too close to Jupiter and ended up being destroyed. So it's a crapshoot for any of these comets when they're going down around the sun. So that's really my talk. I know I went a little bit over an hour, but I hope you learned a little bit about our solar system and the fact that we live on we got the pick of the litter for sure regarding objects. And like I said, so far we have yet to find a similar solar system anywhere else. Ours is unique.
Okay,
So,
I have 2 questions for you. Somebody was asking, where's the best place to observe the night sky if you don't have a telescope? So around Calgary or Alberta, do you have any suggestions? Maybe
oh
take
God,
binoculars?
there's just getting outside the city. You have to remember all the planets are visible to the south. You're never going to have planets off to the north. I know that some people will kind of go out to the west. They'll go out Some will go down south to the Chain Lake area. You don't have to go that far. Um, just I would say get 20 miles out of Calgary, and you can take a pair of binoculars with you. Right now we're just on the tail end of the Perseus meteor shower, and you that is visible in the northeast corner of the sky. And I always tell people, just take a lawn chair and a blanket and just lean back and look up at the sky. You'd also be amazed at what you can see from inside the city. So if you've got a backyard in the shade, in the shadows, go back out there, especially if it's facing south, and just, like I said, have a lay on the lawn and just look up. And you'd be amazed at the number of satellites you'll see passing over. And I also have an app on my phone, and it's for the International Space Station. And I tell
Yeah.
it it's free, and I say I live in Calgary, and it will send me a message usually the day before and say, oh yeah, the ISS is going to be passing right over Calgary. It'll appear about 10 degrees off the west. It'll pass overhead and disappear about 10 degrees to the east. And that's because it's moving in and out of Earth's shadow. And when I know this, I go and round up everybody in my neighborhood. And I said, okay, meet me out in front of my house at 7:30, and we're going to see the ISS going over. And they can't believe it. And I only get the alerts for during nighttime, so you can see it better. But it's passing over Calgary and other places all the time. But it's just kind of a cool thing to get kids out and even adults to it. And I'm like, from Calgary, the International Space Station is really only as just on the other side of Edmonton as far as distance. So it's not up very high. So anyway,
Okay.
it's just a cool thing to do, and you don't need a telescope to do those things.
Well, that's cool. I have one more sciencey question for you. It says, why do Saturn's rings appear opaque? Is there something spinning at high speed or just dust?
Opaque as in like right now.
I guess.
Well, it has to do with the tilt. Was it last year or the year before? The way the way Earth was moving around, and it's just the way Saturn was positioned. But you could see the rings very clearly because it's you're looking at them almost straight down at them. Whereas I mean, Saturn is moving in its orbit, we're moving in ours, and as that's happening, the tilt is becoming less prominent. So now instead of seeing the rings like that, they're slowly becoming so they're just forming a line. You've got so that it's not that they become opaque, it's just the way you're looking at them,
Okay, so they
unfortunately.
clarified. It said in the picture you showed, they looked somewhat solid. So I guess in comparison to what we see based on your photo and then based on what
They're
you'd look
not,
up.
they're not, no, they're not solid. Uh, you certainly couldn't walk on them or anything like that. And I think you could probably pass right through them and you wouldn't even notice it. They're tiny little molecules of ice water and maybe a few little dust, a lot of dust and stuff. But yeah, it's when you do get the chance to actually see them, there actually is something called a Cassini ring, which is that kind of a dark image. Um, Actually, I'll try to go backwards here, show you that Cassini ring. There's the Cassini ring. It's this very dark. It's almost like a space, but to be honest, I mean, this is what's in there. I mean, there is a little bit, it's mostly ice, but there is a little bit of rocky material. But yeah, they're just swung out there just from the gravitational forces of the planet. So it's
All
quite
right.
interesting.
All right. So if anybody is not in Calgary, suggestions if they're interested in learning more or looking at telescopes, suggestions around where they might start looking?
I would before it's always a subjective thing. Some people they love a certain type of telescope, whether it uses a lens or it uses mirrors and stuff. Um, I always say binoculars are your best bet first because you can see a fair amount with binoculars. But um, if you have a club in your area, I would definitely call them up and say, do they have like a rental program with their scopes? And if I mean a telescope is a fair investment. The one I have right now with all its little accoutrements is about $2,000, whereas this newer telescope out there, the Sea Star, I think it runs around $600 to $800, and it is, oh my goodness. So if people are out there interested in telescopes, make sure you do a little work. But the best advice you'll get, non-bias, is go to your local astronomy club and come out to some of their meetings and ask if they have a rental program, and they'll be more than happy to uh, rent them for a month, give you some guidance on how to operate them. Might not be the one you want. And then there's also telescopes that are go-to mounts where once you've got them properly aligned, you just dial in, I want you to go to Orion's Nebula, and it will go there.
Oh,
Uh, some astronomers consider that cheating, but I personally don't. Some of them are hardcore, thinking you should star hop and just know your stars cold. But if you want to get some enjoyment out, it certainly helps to be able to find an object every now and then. And like I said, going to your local club, they'll give you a lot of really good advice, because you don't want to spend a lot of money on a telescope that well, I'll end this talk by what I was told. I went to our local telescope guy and I said, I want to get the best telescope I can get. And I was thinking a bigger one, bigger round one. He said, the best telescope you can get is the one you're going to use. So he says, if you get one that's too big, it's going to take you half an hour to get it out of the vehicle, half an hour set up, and by that time you're cold and life is not as good as you thought it would be, and you'll use it twice and then it'll stay in the garage and you won't use it again. But he said, if you go the next size smaller, which is mine is 8-inch diameter, it comes apart into 3 pieces, fits on the back seat of my vehicle. I can have it put together in 5 minutes, and I can be looking at stuff in probably 10 minutes. Whereas the other person who went the next size bigger is still trying to get his out of the vehicle.